Okay. All right. Hi, everybody. Okay. So now, when it comes to the assignment, a suggestion my suggestion to you is, like, for example, when you have the layout of the building with offices and whatnot. Okay, and so here's the main area of that. So remember when I'm just reminding you that I'm asking you actually to place the J hooks in a circle with the letter J, right? And they will be placed 4 feet apart according to the length of that. I believe that one is 70 feet here. So based on that, you can scale it to this drawing here, and you're going to be able to tell what is 4 feet. So the J hooks should be 4 feet apart. So my suggestion is just to place a bunch of them around the parameter here of the inner hull, whatever it's going to be 4 feet apart. So there's going to be one set of the J hooks, and there's going to be also another set of J hooks. And one of them is going to serve, one of the sets is going to serve the data and the telephone. And telephone and data, but since we're dealing with VoIP telephone systems, there is no difference between the Ethernet cable or the cable that goes to the computer desktop location or wireless access point or whatever active device, the smart active device that requires Ethernet connection, and the phone connection is the same thing, and they're connected to the same thing. They're connected to a switch, so their signal routing takes takes the nature of just a regular Ethernet connection. So the telephone and the data are going to be the same wires, and they should be together, and they should be separate from everything else. In our case, is the PA system. So you're going to have a bunch of circles with the J, 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 J. So that's going to be the J hooks, and you're going to use the highlighter to distinguish between the data and the everything else, which in our case is the PA system. And you're going to use different highlighters for different sets. Now that is supposed to help whoever is installing it just to take a quick look what they need, what cables they need to install and where. So there's no troubles as far as the logistics that have to do with the wire installation. Okay, so this is just to increase or make the efficiency as possible as can be. All right. So you're going to have that. Now, when you have all the 4 feet apart, then when it comes to calculating the distances of the cables, you are going to just count the hooks, count the J hooks, 1, 2, 3, 4, whatever, multiplied by 4, and here's the number of feet. So the cable calculation is going to go nice and easy for you. This type of a job has to do with making quotes or coordinating projects. You are going to experience that, either coordinating jobs for other people, other technicians, or you're going to maybe go in a business on your own, and you'll be able to properly design jobs and properly price it. Okay, so the one thing is to be able to. I get these pop-ups here right now. Sorry, the computer wants to update. We're not going to update now. Sorry. One thing is to do the job properly, and the other one is to get paid for it properly. If you marry these two together, you're going to be successful in something that's called the overall existence. Okay, and so that as far as that. That just came to my mind that you're going to encounter when doing the assignment. Okay? Now, this is technology class here, so I'm kind of concentrating on the job coordination and knowing basically what you're talking about when it comes to properly coordinating a job. So now we're going to take a look at some aspects of cable installation or device installation concepts. And then we're going to take a look at the specifications of the Ethernet cabling. So we do have a lot to cover as always. So fasten your seatbelts, get a good coffee, and let's begin the let's get the show on the road here. Will, shall we? Here is my coffee. You know what? I'm just going to put it aside so it just doesn't stand out here. Okay. All right. So final chats. Let me just take a look at. Yeah, we got 28 people, almost full house, but not quite. All right, but this thing is going to be recorded and placed on YouTube. And before I continue, I'm just going to make sure that we're recording, and I'm just verifying it. Yes, we are recording, so we are safe, sort of. Okay. All right. So, oh, you know what? Before I do that, let me just do one thing quickly. Whoops. You cannot minimize the Zoom when you're recording. Okay. Here, quickly, I am going to post or make the posted lecture notes available. So if you want, you can follow that along just in case the video becomes blurry. So let me just quickly activate the content student notes. Where's the lectures? Lecture notes. And the first set is going to make visible to users. That one there and the other one also. So you're going to see that right now once you log into FOL. All right. Okay, so first page, let's queue up the presentation here and let's start. Right, so cabling infrastructure, installation concepts. The first slide that we have here is the wooden or timber type of framing that you're going to encounter a lot. This is mostly done here in Ontario. It's mostly done in residential setting, like houses and whatnot. When it comes to commercial buildings, you're going to have a steel structure for the most part here in Ontario. However, when in my travels, when I did some jobs over the western part of Canada, I don't know the east, but when I did some western, like Saskatchewan, Alberta, even some parts of BC, you're going to see a lot of timber, a lot of wood in commercial buildings as well. Okay? So now this is not a framing course. However, you should know certain things about the framing because you are going to deal with the framing when running the wires inside the walls, right? So you should know one thing is that you should know what to do, and then you should have some sort of concept of what not to do. Right? Did you ever hear the idea of knowing just enough to be dangerous? You know, so we're just going to try to minimize that. Now, this is just the entry level information I'm going to give you, and the rest you're going to get. The rest of the knowledge you're going to gain on the job. All right, while you're doing the work. But with this thing, when you have this, you're not going to be completely green. You actually know, you will know what somebody is talking to you about. All right. So this is a typical wooden structure. What do we have here? Let me just zoom a little bit more so we can see here. All right, so we have the studs. Usually, the studs are going to be horizontal, and they are 2 by 4, 2 inches by 4 inches. They're slightly bigger, but they're called 2 by 4, and they go from top to bottom. Now, this here is. I wonder if you can see my mouse. I hope you do. So over here in this area, you're going to see like something that's called RO, which stands for rough opening. And this would be obviously a door. So it's a framing designed to accommodate a door. So on top we have wooden, you can call it plates, that are called headers, okay, from the head type of thing. All right, and then we have the studs that go from the top to bottom. And then we have something that's called trimmers. So the layers keep adding on, right? And you have the sole plate and you have the double plate or the head plate on the top. Right? Now, also you have something that's called cripples. and these are the miniature sort of studs just to keep the structure intact. Over here you have the nailer boards that are basically extend in this way horizontally. Also, you can see something that's called nudgings, and we'll talk about that. So it's a very similar idea here. It's just to keep the studding intact, okay? Now, on the right side, this is basically what things look like in reality. Now, what can we see here? We see a bunch of cripples here on the top. We have a typical stud here on the left to hold the structure, and then you have the whole framing that is around the door. Now, when you have complete construction, all that is going to be covered with some sort of a plaster, and usually it's a drywall. So you're not going to see that. So let's say you're going to have to install something that is like a flash door contact for the alarm. What is a door contact? A door contact is a passive switch that operates on when you get the proximity with the magnet. So over here is something that's called a reed switch. I wonder if I can write that thing here. All right, here. Reed switch. What is a reed switch? A reed switch is a switch that is normally open or normally closed. It has the moving part in it. And it's just looks like two little pieces of metal close to each other. Right? And then when you bring a magnet to it, they move. So usually they close. All right. So it operates on a magnet. So here's the idea of a passive door contact. There's no power required to operate this switch, but there is a magnet. So on one, let's say in this part right here, I wonder if you can see the mouse or not. This part right here, okay, you are going to probably install this switch, the switch part right here. Okay. Let me see if I can get rid of that now. Okay, because it has a wire connected to it right here. Okay. So that's the non-movable part, and it will be a frame right here. That will be the frame. So you would install the switch right here, and this is a flash. Now, this picture is a picture of a flash contact as opposed to a surface mount. The difference between the flash contact and the surface mount contact is that this part right here in the flash contact, it gets basically equalized with the surface of the frame. So you can install that thing inside the frame, so it's out of the view. It's a pretty cool concept. And of course, on the other side of the frame, on the door itself, right here, on this door, so the door moves, you're going to install a magnet. All right, so that when you close the door, the magnet comes in close proximity with the switch, and once it's close enough, the switch closes. So the switch is normally, well, it depends which way you look at it. When the system idles, it should be normally closed, but when you take the magnet away from that, the switch is going to be normally open. So you're going to have to pick a reference, which one you're going to see, which one you're going to consider normally open or normally closed. Okay, but you get the idea. Right? So obviously, you're going to install this switch part in the frame that doesn't move, the stationary piece of the whole structure, and then you're going to install the magnet in the door frame because the door moves. If you can't do this, you're going to go surface mount because, well, if you have the whole thing, if the whole construction is finished, the drywall is there, the paint is on, you need to kind of know what's behind that drywall, what's happening around this door frame, right? Around this door. Before you start going haywire with drill bit and drilling things, you're going to spend so much time and you're not going to accomplish anything, then it's good. It's a good idea for you to know. Now, when the best thing for, let's say, for example, a security system or alarm system to be installed in a construction like this, it is before the drywall goes on. All right, so that's a window of opportunity. So that's something to do with the project coordination. When you are coordinating a project, when it comes to that kind of stuff, you need to consider certain things like that. Coordinating with the general contractor, who when is the drywall coming on, when are the air ducts going. So the best thing for the best thing for running a wire in any kind of a building or facility is before the drywall goes on, because you have the freedom of running the wire, and after the air ducts or the HVACs or the air duct people leave. Simply because when the people who installed the crews that install the air ducts, they have a certain job to do and they're going to do it fast. They do not need to understand much about the wiring, so they might touch your wires and reroute your wires or rearrange your wires, not in a way that you would like, and then you might run into some problems. So the best thing is rather to count on, is the air duct person going to know how to go about wires or not, just to be on the safe side. Wait for them to leave, and then you can route your wires around the air ducts, but before the drywall goes on. Right. So when it comes to this, now this header plate. The other mouse. This header plate right here. It's not really hollow inside. It goes all the way through. So there you have a lot of wood to drill through, and you should get a specific drill bit that's basically longer, and so you can drill right through that, so you can run your wires, right? So that's why you need to know this type of construction. So now when you have residential setting, when it's a beautiful house, it's just painted, and they call you to to investigate what would it take to install an alarm. So whenever I got those type of calls, I would ask them, okay, well, first I'll ask them, is the drywall on? Oh yeah. Is your house painted? Oh yeah, we just painted that. Well, you should call me a little bit earlier before that, because before the house is painted, then you can still you can damage some of the drywall in order to route your wiring, and then you can just patch it up and you can paint on top of that. But if the whole thing is painted, then there's not much option except for installing wireless devices. Now, when I was starting with the security alarm business about 20 some years ago, the wireless technology was already there, but it was not as advanced as it is now. So the wireless devices are available, and they're quite good. Of course, there's nothing better than a wire. So if at all possible, you should choose simply wired systems. But if you just don't want to lose the installation, the wireless devices in security alarm business are available, and they are good. So then, of course, the cost of a regular reed switch might be within, sometimes $2, $5 per switch or so on. Then the wireless device, the wireless door contact, and of course would be run on surface mount, which means it's going to be attached to the door frame so you can see it. It's going to be a lot more, a little bit less than $100. So there's a difference between $5 and $100. But just think about it. If you're running wires, you're spending the time of routing the wires through the walls and connecting them and terminating. The device costs less, but you charge more for labor. So it comes up to the same thing. In the wireless device, you charge more for the wireless device because it's more expensive. But you are not using all that time to run the wire to it. So those two things balance themselves out. Right? Okay, so let's zoom out a little bit here, see what else we have here. All right, so this would be typical timber stud partition. So it's a partition wall. zoom in a little bit, and let's get this thing a little bit to the center. Oh, come on. Not yet, not yet, not yet. I'm revealing all this stuff here. All right, so it would be, the stats would be going from the top to bottom, and this would be something that's called nudgings. All right, nudgings, the purpose of the nudging is to, again, is just to keep the structure, just keep the structure solid, all right? So when it comes to running the wires inside the walls, whether it's going to be maybe for a motion sensor for a security device, like for example here, or maybe you're going to have Ethernet outlet for your desktop computer somewhere here. So you can come into that wall either from the top, or you can come in from the bottom, whichever is more convenient, right? In the top, you're going to have to deal with the attic space, lots of insulation, lots of dust. So you need to wear your personal protective equipment, such as dust mask. And one thing, if I can tell you, is if it's summer, then you really should do this thing either at night or early morning times when the ceiling space is not scorching hot. Do not ever go in there in the middle of the day on a hot summer day, because you're going to get a heat stroke, not maybe, for sure. I've seen that happen. It's not a happy situation, okay? And somebody has to go in there and pull you out of it, and you're putting other people in danger of them getting a heat stroke. So just a little side note here, right, when it comes to that. Now, when it comes to installing wiring, when the drywall is, let's say when the drywall is already covered, this whole thing, sometimes you're going to see the nudgings, which is sometimes we call them the horizontal studs, popularly, right? Or sometimes you're going to have them, sometimes you're not going to have them. But if it's a timber construction, it's a wood framing, you can almost count on it that that thing is going to be, and sometimes it's really frustrating because you're trying to pull the wire from the top and you can only get somewhere to here, but you need to go to here, not here, okay? And this thing stops. There is a way to go through that horizontal stud or through the nudgings, but you're also running a risk of drilling through that. And if you don't drill straight, and it involves a lot of skill and a little tiny bit of luck as well, because you're not looking at the drill bit, because you're just going to make a opening right in this on the bottom part, and you're going to try to drill through this horizontal stud while the drywall is on, so you're not seeing that, and you're going to go by feel. Hopefully you're going to hit the middle of that stud or the nudging, so you can go through this wood, but not come out through the wall on this or on the other side. And then so usually I would warn the clients, but then again, you're supposed to know how to do your job. So you either do it or you don't, and sometimes you can warn the client that this is what might happen, and let them make the final decision, or go with the wireless device if you can. Right? If it's a security alarm, you can go with the wireless, but if it's a data, then, well, you know what, you go Wi-Fi, all right? You go the wireless access point, so but sometimes you need to run a hardwired connection. So there is a way of drilling through those. Now, when you have wooden framing, you most of the time going to encounter these, right? So knowing that will help you make some decisions. And the quicker you can make decisions, the quicker and the more decisions you can make quickly, that gives you the opportunity to do your job more efficiently. And when you do the job more efficiently, then you actually are earning money instead of losing money. And if I have to remind anybody that the purpose of doing a work or being in business is to make money, not to lose money, all right? So so that knowledge is going to help you making some decisions, whether trying to run the wires a certain way or plan for somebody else to run the wire a certain way, or just not bother with it and go some other way of maybe put the device somewhere else, or maybe just go wireless, or whichever other options. Let's see here. There, I have put references here for you, so you can click on those links as well. Now, there's a different definition of nudgings. Nudgings were the horizontal bracing pieces used between the wall studs or the floor joists to give the rigidity to the wall or floor frames of a building. Nudgings might be made of timber, steel, or aluminum. Well, here, I'm going to stop for a second. In the commercial buildings, when you see, instead of a wooden frame, you're going to see a steel framing sometimes. Quite often when you have like a warehouse setting or something like that, quite often in the steel studding or the steel framing, you might see that there is not going to be too many horizontal studs, if at all. Right? So you can just run the wire right from the very top to the very bottom. You can drop a piece of chain on the string, drop it down, and catch the chain with the magnet, pull it out, and you have a string, and then you can tie the wire to the string, pull it down, and here's your wiring. Okay, so that's when the steel studding is involved. But we're talking right now about the timber framing. Okay. So nudgings might be made of timber, steel, or aluminum. If made of timber, they are cut slightly longer than the space they fit into, and they are driven into place so they fit tightly. So they're slightly bigger, a very tiny bit. So there's a tight fit. Okay, so that's how they're done. Now, the steel studding is not solid like the wooden ones, question mark. Yes and no, and no and yes. Because the way the steel studding is made, there's a whole science involved in it. Now, I'm not a framer, so maybe a framer would tell you a little bit more of it. But from my experience of dealing with the job site on various hundreds of construction sites over my lifetime, I can tell that there's almost no difference. Right? So, no, maybe in Ontario, you're going to see commercial buildings with more steel framing, because that's how things are being done here. For some reason in Saskatchewan, Alberta, and all those western provinces, I would see a lot of timber in the commercial settings. So I'm not sure what dictates the decision making one way or another. It could be the way they do business there, and we do business here. Who knows? But both of them are good. Right? It's just a preference of the construction. So as long as it's up to code, then it's good. Right? So yeah, you're welcome. Right? Okay, so what do we have here? Yeah, okay, so we did that. Now, when it's a partition wall, quite often you're going to see fiberglass insulation. Now that can be a little stopper for you to run a wire. You're going to try to use the glass rods to push your way in through this insulation and get on the other side. And sometimes you're going to use something that's called a flexible drill bit, which I'm going to show you in the next slide, a little bit down here, from here. So you need something harder to push through, something more snug to push through those walls that are full of the insulation. What do we need the insulation for in the partition walls when it's just dividing one room from another? Well, one is keeping the temperatures intact, and the other one is a big one is soundproofing. Right? If there's no insulation in the walls, in the interior walls, the partition walls, then in the house you're able to tell that somebody has a conversation, or the TV is playing on, or whatnot. So it helps a lot with quieting things down as a soundproofing. Yeah? So that's as far as internal. So then you have to know that if there was no insulation, and if there was no insulation in the walls, and if there was no horizontal studs or the nudgings, then you would be able to just drill a hole right here from the attic space, or from the bottom, from the basement, if this is a first floor. And you would be able to, from the top, you'll be able to just drop some sort of heavier object. Usually those little beaded chains, those bead chains work nice. You just tie it to a string and you just drop it down, and you'll be able to do this and pick it up right at the bottom. Okay, but and also when the house, when you're dealing in commercial setting with the steel studding, that's also is possible, right? So the installation goes much quicker. But when you're going into the residential setting, somebody's house, and you see the drywall just being on top of that wall, of course, it helps you if you know what's actually going on, so you don't lose your time trying, because you know what's happening. And then it, it's all about money. Okay, so also it's going to make you look more legit in the client's eyes. All right. Plus, you're going to be able to do your job more efficiently, and efficiency means money. Okay, so that's what you can expect to see. Now, here's a typical. Zoom in a little bit more. Can we do this here? There we go. Now, on top, there would be joists as well. So sometimes when you can run the wire in the ceiling, if you're lucky, and if you just want to go from this front to the rear of that wall, and if you run into a setting that your joists go with the way you're running the wire, then yeah, bonus, you can run it. But you have to know that sometimes you're going to have the joists that are here in the ceiling, these joists, those things here, that are going to run against you, right? So if you just make an opening here in the drywall and you try to run the wire this way, then obviously you're going to encounter some sort of big time problems here, right? So, so just so you know that. Now, also, here is a dividing wall, or the partition wall here. Let's say there's the room continues that way. It's okay to run wires here, because you have about 2 inches, or a bit less than about 2 inches of free space to run your wires inside the wall. Now, quite often when you see, and the way to check that, sometimes just a quick check, and just kind of bump it with your hand to see how the wall behaves. Is it hollow inside, or is it just basically giving you a hard reaction to your tapping? Like for example here, this would be a concrete wall, and on top of that concrete wall there is a drywall just mounted right on it. So obviously there is no space whatsoever here, right, to run the wires. But what you do is those concrete bricks, the cinder blocks, they do have openings inside. Right? So if you can make your way on top of that brick here, or sometimes you can just go above the ceiling, if you can do that, right? If you go above the ceiling and you just use a hammer or knock out a hole in that opening in that brick, you can find the opening. And those sometimes they're quite often they're going to be aligned, so you can just drop something in there, usually a metal chain. Those beaded chains, they work really nice. Gravity just grabs them, and they kind of go like a snake between all kinds of obstacles, and you can go down with those. The only problem is that in some buildings, the bottom part of the wall is going to be filled with concrete, so you will be able to just drop them inside the cinder blocks right to about here. So it's a hit and miss. Okay, if you know that that they are going there, then yeah. But sometimes you can just if you can, push the fish line in there. And do I have a fish line here? Yes, I do have a fish line. and you can just push it in there and see how far it goes, and you can pull it out and see, okay, it goes from here to here. So yeah, maybe there's some obstruction there, so we won't be able to pull the wire right to the very bottom. Yeah, so that's as far as that goes. Now on the bottom here, there are also joists, and over here would be another floor or another room below that, if it's in the attic space, or it could be a basement. If I can give you any well, piece of knowledge here, if you're ever building a house, it is these days when the communication technology just develops from year to another. The technology that was 5 years ago still being used, but sometimes becomes obsolete. In technology, 5 years can be a lot. You're always going to have the possibility of adding more wires if you need to add an outlet or add a device, or something else comes on the market that needs some installation. So when it comes to having a basement ceiling, it is always better right now in this 21st century right now, is to install something that's called a drop ceiling, which is basically involves a little bit metal grid, and on that metal grid you insert those ceiling tiles. Now those ceiling tiles, when you get some of the decorative ones, they are pretty nice, and the metal grid can also be pretty nice. So yes, you're going to have this thing still looking pretty, and you're going to have the possibility of running wires in this inside in the basement ceiling, so you could go to the reach the walls in your room of the first floor above the basement. Okay, so that's as far as it goes. So you gotta watch if there's a dividing wall. Yes, you're going to have a hollow space here, but you have to make sure that that there will be horizontal studs or nudgings. And of course, when it comes to framing around the doors or windows, you're going to have some extra timber to come across. So the best thing is to run the wires before the drywall goes in. But that's not always the case, because sometimes you're going to have to deal with construction that is already done. So it's additions or something like that. And then sometimes, if somebody wants things to be done a certain way, and you know that it's going to be not that possible, you're going to have to just say, no, I'm not going to do it. Because not only you could get some obstacles in form of horizontal studs or horizontal obstacles or nudgings. You also run in the danger of puncturing some plumbing, puncturing some electrical wires that are existing over there, already exist. It's always your call, but it comes with experience. The knowledge comes with experience. So I would rather say no and not make that $200 or $500 than actually go and puncture somebody's water pipe, and then cause damages that are maybe $100,000. Okay, because when the water comes out, it comes out fast and it doesn't stop. I never had that situation happen, but I've seen it. Okay, I've seen people puncturing electrical wires. I've seen people puncturing water pipes. I've never seen anybody puncturing the gas pipe. You know how you can tell that I haven't seen it? Because I'm sitting here right now. Okay, so think about that. So when it comes to pulling wires or installing wires inside existing walls that are covered with drywall or plaster, or whether they're covered, period, then you need to consider certain things like that. So one is the possibility of doing things, and the other thing is knowing what not to do, so you don't cause a damage, and then instead of making money, you're going to lose your money. Right? All right, so that would be typical framing construction. Now here, I'm going to show you what a flexible drill bit is. A flexible drill bit is a long drill bit. You can see this is a head here, and it's got the screw point tip, okay? And now when you have those lecture notes available, you can go to this. I always give you some reference links. So if you want to find out more about things that I'm talking about, you can always expand your knowledge further. Now this here, it's something that helps a lot. It's got the screw point tip. So when you go, when you feel that you have reached when you touch the middle of the stud, that drill bit here is going to stay, because if you didn't have that screw point tip, you just have the regular drill bit, this thing would slide for sure. Guarantee you that this thing would slide, and it would just go either to this side or it would go to that side of the opening inside. And because the drywall is much softer than the wood, it would take the least path of least resistance, and of course it would come out with through the wall. Right? So once you hit that middle of the stud, or you think you have done it, then you can just make sure that yeah, it is. Plus, when you're drilling, this thing screws into the wood and pulls the drill bit towards towards the front. Okay. Now also you have the flexible drill bit guide. So if you cut out an opening here, you can insert that guide here, and you can direct that drill bit, and you can feel if you hit the wall this way or hit the wall that way, just go somewhere halfway in between. That's going to be half of the stud, and then start drilling. And it's a flexible bit. Some of them are 6 feet long. On the other side of that, you just basically put it in a cordless drill, or usually cordless drill, and you can flex that. That's why it's called flexible drill bit, and it's a long drill bit. Then you can just operate the drill, and you can have that. You can have the opening go from one side to another, and this would usually be, let's say, in the first floor here. And this would be the ceiling space right here, right? And then you would just go and catch that, fish this out. There are different fishing or wire fishing techniques, so you can run wires. But this is how it's done, okay, using the flexible drill bits. Now we're going to look at right now. It's very important. Remember when I told you in the beginning of this class here, is one thing is knowing what to do, but it's also just as important knowing what not to do, so you do not cause a damage. And if you puncture a water pipe, or God forbid gas pipe, then you see the effects right away. But some of the damage that you can cause, the effects are going to take maybe a year or two before they show up. And I'm going to tell you what I mean. This is mostly when dealing with the residential or timber framing right now. The commercial installations are much easier than dealing with residential construction, because they are made simpler. They are made so you can install wires, pull them out, mount devices, and so on. And it's not somebody's house. It's not somebody's home. So yes, some of the commercial environment settings are really nice and decorative and so on. So yes, you also have to be careful. But sometimes if you're doing something like a warehouse or something like that, then you're going to have easier time pulling wires or installing wires or mounting devices or installing the whole system, and it's going to go much faster and it's easier. But the most difficult stuff is that what I'm showing you right now is the residential setting here especially with the timber or wooden framing, which you're going to see mostly in the residential setting. Okay? So a very important thing is to understand what the exterior wall is, and what to do and what not to do as far as exterior wall. Right? So here's the outside, here's the inside, and here is a wall. All right. Got it? Got it. Okay, you're expert now. All right, so now outside there are elements that are quite more harsh than the inside of the house. Right? The idea of the exterior wall is to separate the inside from the outside, so you can sleep at night and nice and warm and cozy when there's a cold blizzard going outside. right? So you don't freeze to death. Okay, so now here's the moisture barrier. Okay, breathable membrane, high-tech textile or oiled paper. Right? Key thing is breathable. It has to breathe. It has to be able to breathe. You don't want this thing to be completely sealed, because if it is, something else can happen. All right. Now over here, it's on this side here is something that's called a vapor barrier. So vapor barrier, impervious membrane, aluminum foil, or plastic. Impervious, it's something like unpenetrable. So over here, the vapor barrier on the inside is supposed to be unpenetrable. And over here, the moisture barrier is supposed to be sort of breathable. So it's supposed to keep things out, but it has to have a soft side to it. Right? And then you are going to put some siding or whatnot to cover that. Weatherproof layer, timber, boarding tiles, whatnot. Okay, so here's that part. Okay, so let's keep going with that. There's no more here. Yeah, nothing to the right or to the left. Here is inside. This is what a vapor barrier looks like. And I'm sure you have, whenever you have walked into a house that's under construction, you're going to see something like this. What can you tell right away on here? Well, to my surprise, and I chose the picture on purpose, look at that. There is no nudgings here. Bonus. If you want to do something, it's a good idea to, if you're involved in some sort of construction, it's a good idea to take a lot of pictures before the drywall goes on for the future reference, and keep them somewhere that you can find them later. Right? That's the key too. So you're going to see something like that, and you're going to see the foil, the moisture barrier, and you would just put from top to bottom, and it just stuck to the wooden studs, quite often stapled to the wooden studs and whatnot. And you're going to see that red tape. What is this red tape? It's not because the government came here and they put some rules and regulations and they call it a red tape. No, it's the other red tape. It's called tuck tape, like tucking in. Let me tuck you in, okay? Tuck tape. So that's when you put that, you basically are sealing that. So if there's one piece of the vapor barrier here, and then there's another piece here, they join here. So then just to make sure that this thing is unpenetrable as much as possible, you're going to close the gaps with the tuck tape, and all that goes to all the openings that are there. All the outlets, all the switches, they should be sealed from the outside, because this is an outside wall and this is an outside wall. Obviously, you can actually see the window here and you can see a window here, right? So both of these walls are outside or exterior walls. And you're going to see that vapor barrier there. And then you're going to see some insulation. And on the other side, you're going to see a breathable barrier, all right? So it's not supposed to breathe as much from the inside, and it's supposed to be breathable from the outside. So there's some sort of gases exchange. Okay. Now, when you're installing a device, okay, when you're in a room and somebody's going to ask you to install data outlet or a telephone outlet or electrical outlet, if you can do that, and you're authorized to do that, then I would take a look, and I would prefer to not disturb the exterior wall as much as I can. So first of all, I'm going to look and try to say, okay, would it be okay if it was on this wall instead of, and if the answer is no, then it has to be done. Then you're dealing with having to deal with the exterior wall the way you're supposed to deal with it. And sometimes it gets a little bit messy because you're going to disturb some drywall, and then you're going to have to patch it up and paint it later on, maybe, or you tell the client. That's what, you know, that's if the drywall is already on. You can't just drill a hole, install an outlet, and walk away from it. Right? That's when it comes to exterior wall. Those outlets and devices that are mounted in the wall, they are supposed to be in something. Oh, I'm pressing control here, but it's on a different keyboard. In something that's called a Polypans, right? Polyethylene. So you install, you make an opening, you install that polypan. So it's basically a plastic panning there. You seal that off with the tuck tape. You see that here? All of those are basically sealed off here. And then you make an opening here somewhere on the top or somewhere on the bottom or whatever you need to, just to run the wires into the device or the device box. And you also seal that opening as much as possible as well. Right? This way you are separating everything, from the inside from the outside. If you install the outlet without protecting it as a vapor barrier, then you're going to run into a risk of creating a huge mess. And we're going to talk about that in a second here. Here are examples of installing polypans. And here is the sealing or sealant, or not the sealing, but sealing as far as protecting, right? So everything is separated. Right? That's what we're supposed to do when installing devices. These are electrical devices, but that also goes to everything else, telephone, data outlets, and whatnot. Right? So here are some references. Once you download it, you're going to be able to read more if you wish. Here is what happens if you mess this up. Well, this happens because you're going to have improper exchange of gases. Some of them are going to be trapped, or the moisture and gases, like air. Air is a gas. Some of that is going to be trapped when it needs to be breathing, and some of it is going to be breathing or getting through when it's supposed to be kept away. And things are going to happen. You're going to grow mushrooms. And black mold is one of the biggest thing that can happen. And it's not very hard to accomplish. Okay, all you have to do is just do the job improperly and walk away. And within 2 years, or maybe even earlier, somebody is going to deal with that. Okay? It's more than just annoyance, because it's a health hazard. Okay? That's what the black mold looks like, and that would be inside the wall with people not knowing it, but they'll be breathing it. So that's a health hazard. Or sometimes you're going to see the signs of it poking through the drywall. That's also a sign of black mold. Right now, when I'm not trying to teach you how to do proper framing, because that's not my job. Plus, I'm not going to claim that I'm a framer, because I'm not. However, I want you to know what's involved, because when you're installing the wiring, you are going to be touching it. And I want you to touch that and work with that in a certain way, so you don't cause the damage, so you can actually do some proper things. Okay? So let's talk about the black mold a little bit. The most common black mold symptoms of health effects are associated with respiratory response: chronic coughing, sneezing, irritation to eyes, mucous membranes of the nose and throat, rashes, chronic fatigue, and persistent headaches can all be symptomatic of black mold exposure or black mold poisoning. These are just the tip of the iceberg. It can create some really bad chronic problems. Have you ever found mushrooms? Well, when I was in Europe, we used to go mushroom picking, but it would be different mushrooms. It would be the edible ones, right? But have I seen some black molds in during the time that I used. Yes, once upon a time you get, and you smell it. It smells a certain way. It's that stingy type of a smell, and you actually you can tell. So once you smell the black mold, the best thing is, you know what, just get out. Right? You don't want to breathe this thing for a second, because that thing can grow in you. Right? I'm not a doctor, but I don't need to be a doctor to tell you that if you see black mold, get out. Right? Don't be in that room. Right? Now, and let people deal with that who are actually trained to deal with that. It is actually possible to get rid of black mold. It's not easy, but it's possible. But just don't try to do it yourself. Just don't use just like a watch YouTube video or something and think that you're going to be able to do it. Please don't do that. Right? Now, in particular, severe cases of prolonged exposures, black mold health effects can be more dangerous, often compounded by allergic reaction to black mold spores. These spores, those spores are basically those little things that grow out of it. These symptoms can include nausea, vomiting, bleeding in the lungs and nose. Do I need to be a doctor to tell you that it's not good to have bleeding lungs? I don't think I need to have doctor's credentials. You know what? It's not good to have bleeding lungs. I can say that, right? And not get in trouble. Now, okay, so here are some concepts again for this, as the exterior wall and the vapor barrier and their functions here. So exterior walls, let's see how the time, okay, we're going to take a break soon. Exterior walls give the shape of a home, give the home a shape, all right, provide the structural support and protect the home from outside elements. Exterior walls are an essential factor to in insulating the home and keeping out the moisture, mold, and more. And here are some reference. You can go on once you download this. Now let's talk about vapor barrier here. It's a layer of material such as roofing paper or polyethylene film used to retard or prevent the absorption of moisture into a construction such as a wall or floor. So it's supposed to retard the absorption of moisture, which means that wall is supposed to be breathable from outside, not completely sealed, because if you completely seal it, some of it is still going to get through and it's going to be trapped. And if it's trapped, it's going to start growing things, right? So some breathability from the inside of the wall out is actually recommended. And how it's done, there's a whole science. I'm not going to get into it, but just so you know that the walls need to breathe a certain way. Yeah? Now, the function of a vapor barrier is to retard the migration of water vapors. So slow it down. Right? Depending on location, so depending on where you are, you could be in the moist Ontario climate, or you could be in dry Saskatchewan climates. Some of the construction and some of the details of how they do things could be a little bit different. Okay, depending on location, the assembly and its permeability is a function of. Now, here's the word permeability. I'm pretty sure you studied that word when you have studied the magnetism. And just as my reminder, what is a permeability in magnetism? Permeability tells you is the measure of how easy or hard the material can be magnetized. Okay? Now, permeability of a vapor barrier is how easy it can be. It's a measure of how penetrable it is for the water, vapors, or other gases such as air. All right. So it depends on the permeability of depending on location, the assembly and its permeability, which is the penetrability of the vapor barrier, is a function of climate, right? Characteristics of the materials that comprise the assembly, and the interior conditions. Right? If you're not completely sure of what you're doing when you're doing some alteration to your walls, especially the outside walls, you can almost count on that you're going to do something wrong and you're going to cause the problems in the future. So that's, the black mold is not something like a puncturing water pipe that the water starts coming right away, and you're going to see it, and you're going to feel it. But that thing creeps up on you, and it can cause a lot of damage during the extended period of time. So again, also vapor barriers are not typically intended to retard the migration of air. That is the function of air barriers. Okay, so vapor barriers. So that the walls should protect you enough from the environment, the outside environment, but they should provide a proper interface between the outside and the inside. So it should have enough protection, enough separation, but it should have the right amount of breathability. So that's why it is important. Otherwise, the biggest thing is you running into risk of getting a black mold. Permeability here, state or quality of a material, in this case, okay, not in magnetism. Permeability is a state or quality of a material or membrane that causes it to allow liquids or gases to pass through it. Permeability. There you go. Brought to you by. We're almost done with this thing here. Let's just take okay, maybe 5 more minutes because we're almost done here, and then we're going to take a break, and we're going to continue with the second part of this class here. All right, so what do we have here now? Cabling infrastructure concepts. Cabling infrastructure concepts. So that we talked about what you might run into and decision-making process as far as which way to run wires and which way not to, what to do, what not to do, what to pay attention to, what to be careful of. Right now, I'm going to present to you the stages of running or installing cables and, as a matter of fact, devices as well. Right. So I have listed first something that's called a rough-in. I've listed this first, but that's not the first stage. I'm going to tell you the first and last stage at the end. This is the meat and potatoes of doing things. But we have to do something first, and then we have to do something last. So let's start in the middle here. Roughing in. All cables are brought to location at both ends, destination and the home run location. Right? So when we have the assignment, the destination of every cable run would be like a desktop. And the home run would be the LAN room or the communication room. LAN stands for local area network room. So you just run the cables and leave them there. You bring them to location, destination. In the destination, you coil the cables in the ceiling for the most part. You just don't want them to be damaged when other people are working on their jobs. And the home run, you coil all the cables in the ceiling space or safely on the floor. Depends, you just have to have them safely tucked away. This is a very small home run here or destination, and you can. So what? Did I do that or somebody else? I'm not sure if this is my picture or I, done so many jobs. And here you just run those cables and put them in the foil so they don't get damaged or painted on or whatnot. So this would be a small home run. Now, zoom in here. In the destination, as you could tell, see you run the wires above the ceiling and you punch out the hole here or opening and you just coil them here. Coil them here. Just run them from one end to the other. Run them from one end to the other, from one end to the other, and leave them there. The purpose of that is the efficiency of doing things. You just use for certain jobs, you use certain different types of tools. And if you can speed up, if you can automate the process, then the process just goes that much faster. So if you just use one type of tool, like a ladder or step ladder, and maybe side cutters and a piece of tape and a marker or whatever else, you just go as light as possible and just do repetitive action. If you can create a repetitive action, then the efficiency just goes high, right? And you want efficiency, right? So, roughing in, it's a very common term that's being used. How much do you charge for this? How much? Okay, so you know what? We're just going to rough in the cables and we're going to charge you this much for roughing in. Maybe somebody else can do the installation, or you just do the installation in stages up to roughing in. Please give us a paycheck for that much money because this is the milestone complete. it's a good idea to have milestones, because if you just never ever try to never ever do this job from the beginning to the end and say, you're going to pay me when I'm done the job. Please try not to do that, because what happens is that at the end, the client has a lot of bills to pay. And if you can wait, he's going to make you wait. Right? So try to charge the client in milestones. Right? So this way you get your money. And quite often, some companies, the construction companies or clients, they go bankrupt, and they don't have to pay you money when they go bankrupt. So just a side note, right? So here is the roughing in. You pull the cable to the destination, and you pull the cables to the home run, and just leave them there. So here will be the destination wall box. You just coil them there, and then after the rough in, and the rough in can be anywhere from half a day to a month, depending on how big the job is. All right. So now we go to the next stage, will be the destination prep. And that usually takes 2 people. Right? I have left side of the screen and the right side of the screen here. So this will be the destination preparation or the installation at the destination location. So if there are 2 people, 1 person can go and just pull the cables down to location, maybe drill some extra holes here, okay, and then put them into the device boxes, and even terminate the wires, terminate the connections. Or sometimes you leave them there and without terminating, because you wait for the drywall to come in and the paint. So that depends. Quite often you're just going to leave them or call them in the boxes, and there's going to be one other sub stage of coming in and just do the final termination. Right? But at any rate, you're going to have 2 people. That's the best thing. That's more sufficient. 1 person hits the field and terminates all the jogs in the field using the same tools repetitively. And there's another person here that goes to the head end. Now I know this is my picture, because this is a job that I have done some years ago, and I sometimes will be just taking pictures just for kicks. And this, you see here is the home run location, all the wires coming in, and they were coiled up in this area. When I was, sorry, let me just get this here. I would just call them up here when I was roughing them in. And when it comes to the destination prep or termination, I would just uncoil that. I would cut them to length, transfer the numbers, because the numbers on the wires would be all over the place, somewhere towards the end, and so there will be different lengths. So I would just transfer all the numbers or the labels to one specific place so I could find them easily. And then I would just do the routing. Maybe I would do a service loop. And somebody asked me what a service loop is. A service loop is an extra coil of wire at the location. So if you need to, for whatever reason, if you need to grab some extra length of the wire later, you can pull that from that service loop. And usually it's like a 10 feet or something like that. All right. So in our assignment purposes, we just said that we're going to have a service loop. All the wire, every wire is going to have extra 10 feet just before it hits the patch panel here. And these are the patch panels. And on the other side, there are going to be service loops, which I don't have them here, above the ceiling. So 10 feet at the destination and 10 feet at the home run location. That's every wire is going to have 20 feet of the service loop. Plus, you're going to have 10 feet going from the ceiling to the floor, and 10 feet from the ceiling to the floor. So every single run in the assignment that we have is going to be no less than 40 feet, because you have 10 feet service loop at both ends, so that gives you 20 feet. And then you have 10 feet from the ceiling to the floor on both ends, so that's 20 plus 20 gives you 40, all right? So don't forget that, all right? So that's the destination preparation here. And that's there are some examples of the destination, the final termination. All right, so termination. Okay, sometimes you just do the you can do the termination right away, or sometimes you have to wait for the other crews, the other construction crews, other trades to finish their job first before you can do the final termination. Because if you do that, they're going to not be able to do their job, and if they do that, there's a chance of things getting damaged. You know. Things can be painted, jacks can be painted. That's no good, right? So here's one example of a final destination. I did that job long time ago. That was pretty interesting. I just did it all by myself. I didn't want a helper, and then I was kicking myself for it halfway through the job. I said, I said, I need two people for that. I just wanted to make more money, but I was sometimes. And then there is example of a termination at the head end, okay, which is, this is not my job. I got this thing here from somewhere else. All right, but so that's pretty much it. And you know, either stage, depending on the job, can be from a couple hours, half a day, to a month or 2 months, or sometimes 6 months, depending on how big of a project it is. Right? But now I said, but first. So remember, I just told you the core of the more or less core of the wiring or the device installation or the systems installation. First, we need to do the plan. We have to do the planning first. There's a couple of my friends, actually, we did that in one of the locations in London. I'm not going to tell you where that is, but after it was done, it looked pretty different, just a commercial type of thing. So here's this, obviously, right away you can tell that these are the steel studs here. Right? So what do you see? These two guys here, my friends, they have, and I was running around with them, and sometimes I would take pictures because we did the job, the three of us. So we had all notepads to write on. It's called a survey. A survey is, remember I told you last time, if you don't remember, I'll tell you again. Survey is going onto the site and making notes. What needs to be done? What's the state of the site? What needs to be added? What needs to be performed? And how it needs to be done. Right? So that gives you the idea of what you need to purchase and how long it's going to take you to complete the job. All of those items are extremely important when pricing the job, because when you're pricing the job, you can make or break your business. You price it right, you make money. You price it wrong, you spend a bunch of time. You're going to lose the time and you're going to lose money. So pricing the jobs right is extremely important. So this is an extremely important part of the job, is doing the survey. Okay? And of course, the famous deliverables. You see, I'm putting a great stress or great deal on filling out the deliverables properly, because this is how you make sure that you get paid after you have done your job. You get the proper documentation. You can spend 6 months on doing the job. If you don't document it properly or the way they ask you, you can get paid less, or you can get the payment with a delay, or sometimes you just don't get paid at all. Very rarely that, but it happens as well. So this is a different work order from a different company. Obviously, I blanked out the signatures because obvious reasons. And I just put a bunch of things. So you take pictures. This was one of the pharmacies in Brantford that we did years ago, and you do the as-built pictures or the deliverables as they ask you. And I ask you to take a couple pictures just for practice, but sometimes you have to take 40, 60, 80, 100 pictures, and they have to be done in certain ways. So we're doing the practicing, we're doing what you're going to have to do later on. All right, so that is more or less the concepts of running a wire. You might want to rewatch that video again. Now over here I have the yays or nays as far as installations. Is this yay or nay? If you see an installation done that way, I think it would be big yay. All right, so that's a good that's take a lot of skill and talent and experience before you can do something like that. And this, I'm telling you, this was not done in one day. This is a 6-month job or something like that. Right? Now let's see the next one here. Is this yay or nay? Believe it or not, I have seen things like that. This is a LAN room that is really terrible. Try to troubleshoot something like that. Plus, there's a possibility of something going wrong, not to mention the blockage of the airflow. Okay, so it's a disaster waiting to happen one way or another, and one way or another. And more or less, you're going to see similar situations, not maybe in that scale, because that's a, you know, that's a rarity, but still you're going to see similar things. So obviously this is not a good situation here. Another one here, that's a good one, right? That's a lot of wires. They look to me as Cat6 wires, especially in the, you see lots of Velcro being used in that, and some other straps, but no zip ties are being used, because if you use zip ties on the category or Ethernet cable, you are compromising the structure by squeezing the wire. And once you squeeze the wire, you are altering the physical parameters of that wire, which means you're altering the specifications of that wire. So Velcro is the key. That is a good installation and takes a lot of experience, knowledge, and skill and time to do that. And there is something else here. Is this a good installation or not? That looks like a neighborhood telephone box, telephone branch out thing. Try to troubleshoot something like that. I wouldn't even touch that because I would be the last one to touch it, and you can breathe on it, something can get disconnected, and that's going to be your fault. So I'm just giving you the idea that you know, when you're dealing with communications in this form, or telecommunications in this form, there's a lot of wiring involved. That's why a great deal is being put on neatness, because when you have 2 or 3 wires to run, you know, if you make a mess with 1 or 2 wires or 3 wires, no big deal, okay? But if you have 600 wires to run, you better have some sort of a concept of structure that you're going to apply to that installation. Because if you don't, you're going to end up with something like this. All right. All right, so let's take, what time is it? It's 4:15. Let's take 7 minutes, or let me see here. 17, 20 plus 5, 25, all right? Yeah, on our phones, let's meet back here at 4:25. Yeah. So go and stretch, and I'll pause the recording, and I'm going to, when I come back, I'm going to announce that I'm going to announce that I'm going to snooze the update. I'm going to announce that I'm going to resume the recording, and if you don't hear it, please let me know, because we don't want this thing to be not recording. Okay, 25 after 4. Let's meet back here and continue with the recording still. Okay, so we're back. The back is back. Okay, so now what we're going to do, I'm going to queue up another presentation here. So just give me a couple seconds while I do that. Here it is. All right. This screen and my beautiful face on that. There you go. Aren't you lucky? Yeah. Okay, so category cabling, right? This is a picture I took when I was having a personal grand tour of one of the huge facilities here in London, Ontario. I'm not going to tell you what the facility is, but it's a real, I took that picture. Yeah. Now, let's say these were Ethernet cables. Does anybody see any problem so far that we have talked about? What's wrong with this? If you can see it clear. Zip ties, all right? Thank you, all right? That would be wrong. If, you know, this is not a very good idea to do that. Because look here at this, you can actually see those cables being deformed. And once you deform the structure of the cable, you're altering the specifications of those cables. So there we go. Dylan, congratulations. Can you spot any cabling faults here? Yes, zip ties. What should we use? We should use Velcro. All right. Data cable bundles should be bound by Velcro tape. Soft side in. And Velcro sometimes comes in big bundles like this. Okay, you just get them and you just cut them to length and you use them. Sometimes they come in different colors, whatnot, smaller bundles as well. And this is how you do it. Now, I'm not sure if you can see this. Is it clear enough or is it blurry enough in the live Zoom presentation? You're going to see a clear picture when you download, if you haven't done so yet, that there's something wrong. And I found that there was a somewhere on the net, somebody was presenting on how to do this, and something was skipped, some concept was skipped. Anybody can tell what is wrong with that if you can see it, if it's clear enough. I'm talking about this bottom picture right here. Okay, not going to spend too much time on that. In the beginning, when I talked about Velcro, I said soft side in. Thank you, Dylan. There we go. Soft side in. All right. This is not soft side in. Not a huge deal. However, soft side in should be considered. All right. So here it is. This is wrong. The soft side of the tape is on the outside of the bind. All right. Okay. Now, here is a rod, or let's say that this is what I could come up with my artistic abilities of drawing things, of running or drawing a straight piece of conductor. All right. You're going to see where I'm going with this. Here's an arrow. Right. This represents the current flow in this conductor. When there's a current flow in this conductor, there is going to be an electromagnetic field that is surrounding that conductor, and the direction of the electromagnetic field is just if you were having a corkscrew, and you would turn this thing righty-tighty and the corkscrew would move forward. So the forward motion of the corkscrew represents the current flow, and the direction of turning would be representing the direction of the electromagnetic field. All right, with me so far? All right, let's get rid of the corkscrew. Now let's put another wire right beside it, and you can see where I'm going with this one here. So the wire that's in red, it's an active wire that has electric current flowing through it, and the other, the blue wire, is just put in proximity with that wire that is active. What is going to happen? That electromagnetic field is going to affect the other non-active wire, and it's going to cause electric current to flow through it, just because it is going to have an electromagnetic field surrounding it. So it is called induction. So the electric current in the blue wire is going to be caused by the phenomenon that is called induction. It is a very popular thing that is being used in transformers, for example. So this is when induction plays a good role, when you are running, if you're building an electric transformer. But we're not building transformers here. Now we're dealing with telecommunications links, wires, cables, pairs, right? Signal paths. Right? So the blue line here is that the electric current in the blue wire is going to be caused by induction. It's going to be inducted. It's going to be induced in that non-active wire. Okay. So now we're going to come to the idea that's called a crosstalk. All right. Let's talk about crosstalk. In electronics, crosstalk is any phenomenon by which a signal transmitted on one circuit or channel of a transmission system creates an undesired effect in another circuit or a channel. So it's a bad thing. All right, crosstalk is usually caused by undesired capacitive, inductive, or conductive coupling, which is affection or connection, from one circuit or channel to another. Right? In structured cabling, electromagnetic interference from one pair to another. So one pair which in close proximity to another pair, then we're going to have that's called a crosstalk. How is the crosstalk being eliminated? Okay, let's say crosstalk analog. So let's say we have a conversation of two very pleasant people having a good conversation, which is very civil, very pleasant, and all that stuff. And those two people, those two wonderful, calm people are having a very pleasant conversation. Let's say there is another pair of people that also are having a very pleasant conversation. And somewhere along the line, those cables that are connecting these two pairs of people, those cables are going to run in proximity with each other over a certain length. So by the same principle or the same phenomenon of the induction, some of those, the one line can pick up the conversation of the other line. This was a very common thing when the POTS systems were implemented. So up to 70s, 80s still, you would have that a lot. I remember in 80s, occasionally there would be, I'll be talking on the phone with someone, and then all of a sudden I would just, some other conversation would fade in, right? Sometimes you could only hear that other conversation, or sometimes you could actually talk to the other people, and sometimes those conversations were not very pleasant. It was one of those things. Right now, you're going to see less and less of that thing, just simply because the technology is different. There was a way to solve that, okay? Now, crosstalk, I encourage you to take a look at some of the this YouTube video here. I'm not going to play it here, but once you download this, just click on it, and there's going to be a demonstration of a crosstalk. What happens is crosstalk in a digital line. Okay, so I'm just going to make a long story short with that one. In analog transmission, when you have a crosstalk, you're going to have annoying interference. But you're still going to hear yourself, your conversation. You're going to be able to conduct your conversation. Is that you're going to be annoyed with something cutting in and out, or fading in and out, or bleeding through. Right? All right. Like, for example, there is, I'm trying to talk here, and there's an interference here. All right. All right. Cool. Now, when it comes to digital transmission, as you know already, because you have spent enough time in our walls to learn some of that, how is it that digital transmission takes place? It takes place by transmitting ones and zeros, and quite often those ones and zeros are being synchronized by either synchronization reference type of a signal, or timing that you're going to have a certain signal, and you're going to be a string of ones and zeros, and they have to fit exactly within a certain time frame. So when on the other side, after some time, that other receiver is going to get the starting point, is going to start measuring time when the receiver receives those ones and zeros, and based on that, the communication is going to happen. The receiver is going to understand what the transmitter is trying to tell that receiver. Now, when you have some interference, you're going to have some ones and zeros injected in between those ones and zeros that are correct. You're going to have some ones and zeros, or the spikes, that are incorrect, and that the receiver is just going to get confused. There's no way it's going to make heads or tails of what is happening, what that transmitter is trying to tell, and it's just going to shut down. Right. So in analog transmission, you get annoying interference, and it could be audio or video or some other things. But even if it's a video, you would see a football game, and all of a sudden some other picture would fade in and out of some other adjacent channel or something like that. You can still watch that game, but you're just going to be annoyed with other things coming, cutting in and out. With digital, there is none of that. It's either a full understanding of the message, or if the message is not understood, the receiver just goes, nope, you know what, I'm done, say it again or something. I'm just not going to display anything. And over here in this link, you're going to see extreme example of crosstalk interference in a digital transmission. Now, of course, it's not always like that, because quite often you're going to see bundles of digital wires, Ethernet wires, and somehow they are not interfering or not interfering enough with the digital transmission to cause the transmission failure. Right? But this is that link here. It just shows the extreme condition. That's why sometimes you should choose something that's the wires that are shielded, as opposed to wires that are non-shielded. Okay? So this thing brings us to something that's called UTP. All right, the UTP stands for unshielded twisted pair. Let's just say twisted pair that is not shielded. Twisted pair was it's not a new invention. It was actually the concept was invented by Mr. Bell, Alexander Graham Bell, the inventor of the telephone, some time ago, to eliminate crosstalk. What's happening here? You can see that these pairs have a twist. What does the twist accomplish? Well, when we twist the pair, the electromagnetic field that is being caused by the electric current flowing through that pair doesn't have, it's not constant, right? So it's kind of dispersed in different directions. So it doesn't have as much strength to induce itself onto another pair. And then if you have another pair beside it that is also twisted, it's not going to have enough area that is going to be equal with the other area. So the field is not, it's not going to be as susceptible to the interference from the other pair. And then on top of that, you're going to twist both wires at a different rate. So now it's another obstacle for the interference to overcome is that not only they are twisted, they're also twisted at a different rate. So there's no constants, there's no regularity in that. So that's how this crosstalk is being, for the most part, is being solved in the in telecommunications. Now, does it eliminate the interference from one pair to another 100%? No, it doesn't, but it cuts it so significantly that it's almost becoming non an issue, right? But it doesn't eliminate it 100%. Okay, so unshielded twisted pair. The purpose of the twist is to eliminate the crosstalk between the pairs. All right, now we're going to go into something that's called the STP, which stands for shielded twisted pair. Twisted pair. Right? So the pairs are not only they are not only twisted, but they are also shielded with aluminum foil, for example. Right? Most of the time, you're going to see aluminum foil. So you're going to see the aluminum. Okay, so in this cable here, every individual pair has individual shield around it. So it is twisted, plus it has a separate shield around it to prevent the electromagnetic or the interference to get through that. So it's like the shield metal acts as a screen. Okay, and then it has something that's called a shield wire or a drain wire, and usually that would be connected to a ground terminal or a bond terminal. The difference between ground and bond is that they should have the same potential, but the grounded terminal goes straight to a ground, a spike driven into a ground, so true ground. If you take another terminal off that terminal, and you also connect that to the grounding terminal on for another device, that device is also technically grounded, but because it doesn't go directly into ground, it goes through the ground through another device. It is called bonded. That's the just FYI. Right? So now, although the unshielded twisted cable is the least expensive cable, it might be susceptible to radio or electrical frequency interference. It should not be too close to electric motors, fluorescent lights, or anything that buzzes and makes noise. Other things that produce a lot of noise would be the thermostat control wires. There's a lot of signaling going on in there, and that's one of the biggest noisemakers. The other devices would be security alarm wires. They're also big noisemakers, so you would try to stay away from that, or anything that you can see as electronic or electric device, maybe some relay switches or something like that. You want to stay away from that at least 1 foot in the construction environment here. Okay, so shielded twisted pair cable is available in mostly 3 different configurations. Configuration number 1, each pair of wires is individually twisted with a foil. So that's one option. Another option, there is a foil or braided shield inside the jacket covering all wires as a group. So the wires are as a one cable, and then they are just embraced by one common shield. So so instead of all the, I get the idea. Or you can have both. You can have each and every individual pair individually shielded, and then on top of that, you will going to have a common shield. This is the most common thing. There are certain ways of installing they're using different, more expensive jacks. Of course, the wire cable is more expensive, way more expensive, but sometimes you have to use a shielded pair cables. Where would you mostly use those shielded STP shielded pair cables? In the industrial environment. So if you have a building that is basically an office building, and you just run the wires from the LAN room to the desktop locations to accommodate the computers and whatnot, then by all means, for the most part, you get away with the unshielded twisted pair, which is UTP. But if you are installing a network or control wiring that employs Ethernet communication, in something like a production plant, when you have robotics going on, machinery, PLCs, all that stuff, the control systems, then I would say almost 100%, if not 100%, you're going to be required to install shielded twisted pair, because those wires are running along the machines that have motors or whatnot. There's a lot of interference. There's a lot of electromagnetic interference, noise, or whatnot. Then you need to have a shielded pair. So that, for the most part, that you're going to have that shielded twisted pair installed in that kind of environment. Okay, so before we go to the next slide, I'm going to preamble that with this slide here. CCA, right? Copper, cladded, aluminium, as they say in UK, or in North America, they would say aluminum. Same thing. All right, copper clad aluminum or copper cladded aluminum. What is it? Well, if you magnify that, it would look like this. It would be aluminum conductor just coated with copper. So you get the copper properties of a wire. The purpose of that is to save cost, because copper is more expensive. So you get the most of the core of the wire is aluminum, but you are just cladding it with copper. These would be the less expensive cables that you would buy. As a general rule, I would say stay away from that. That's all I'm going to say about that. Right? Try to get the bare copper wire. It is more expensive, not that much. Well, it is more expensive, or the maybe the copper wire, the pure copper wire, would be the proper price. And in order to save the money, somebody invented the CCA, copper-cladded aluminum, to save money. Right? That's the only purpose of that. So that would be less expensive or cheaper. Okay. So now once you get the concept of that, I'm going to move to the next slide. All right. So you're going to keep that table. That's going to be your roadmap here. Actually, you know what? Let's just go in there and then find them. We should be fine. Yeah. Sorry, we just had some delivery here. So here is the table of specifications. You're going to print that table and you're going to use it as your roadmap for Ethernet cable installations. Different categories: Cat5, Cat5e, Cat6. You know, we don't even list the Cat3 cable here. When expecting contracting aluminum, crack the copper coating. When expect contracting. If you come again on that, I'm not sure what you're saying here, Sean. Sorry. One expanding the contracting aluminum, crack the copper. Oh, I see. Okay. I'm not going to get into the science of things because, frankly, I never thought about doing the scientific examination of that CCA copper-cladded aluminum. But I'm just going to say it's not pure copper. There's an aluminum part in it. It's not as good as conductor as pure copper. That's all. You know, you see it. It's less expensive. Don't go for that. Just try to get the pure copper, and you're going to be fine. You're not going to get so many annoying service calls or things like that. Right? All right, so let's take a look at this cable here. So on the left here, we have different categories: Cat5, Cat5e, Cat6, Cat6a, 7, 7a, and 8. We're not going to go any further because I'm not even sure if there's Cat9, because you might as well go with fiber. Actually, you might as well go with fiber instead of Cat6a, in some cases, for the different reasons. Price is one of them. Okay, so Cat5, which is pretty much obsolete anymore, but you're still going to see some of the older installations there, right? The gauge is a 24 gauge. How does the gauge work? American wiring gauge, AWG. The higher the number, the thinner the cable. The lower the number, the thicker the cable, okay? So that's how the gauging works. It does have a little bit of a twist. Now, the transfer speed versus the bandwidth, okay? The transfer speed is 100 megabits per second. We're not saying megabytes per second, because if we're talking about bytes, we're talking about storage on a hard drive, for example. But we're talking about speed, we're going to talk about megabits per second, or bits per second, or gigabits per second, or megabits per second. So transfer speed of the digital transmission would be 100 megabits per second, and the bandwidth, it's also going to be 100 megahertz. How does one refer to the other? This is the digital transmission sending the digital pulses, ones and zeros. So that's as fast as it can transfer without the data tripping over its own feet. And this is what frequency at the most you can send an analog signal through that cable, and the signal is still understood on the other end. Okay, and the maximum length of that Cat5 would be 300 feet. Actually, to be exact, it would be 328 feet. However, it is just taken that 300 is easier to remember, and you try to stay away from the 328 feet end to end, because you still are going to have things like connections, terminations, and maybe patch cords and stuff like that. So that extra 28 feet gives you a nice cushion, for having that. Just so you know, if you have a connector, that it's just like adding 10 feet to the overall length. Okay. So the maximum length of that is 300 feet, and you can transmit 100 megabits per second. Now, that is, you're not going to see new installations, new network installations using that. However, you're going to still see a lot of older installations still there. You should be able to tell. And how do you tell? You read the jacketing. You look, there's an imprint on the jacketing. And this, if you have enough experience, you can just tell almost by touching it and by looking at it. You can say, oh, that looks Cat 5, like Cat 5. Oh, yeah, it is. Right? So then we're going to have Cat 5e. The gauge, still 24 gauge of the conductors. It has a tighter twist, and it is capable of 1 gigabit per second. So that's a bit of a difference here, eh? There you go. And then here is what we talked about before, the bandwidth, all right? The analog signal. It is capable of transmitting 100 megahertz of analog signal when we have copper-cladded aluminum, or it is able to have 350 megahertz if it's a bare copper, BC. So that's where this thing already is playing a role here, right? Where is it used? In home network installations, small offices, and commercial. You're going to see a lot. The Cat 5e is still going strong. You get the most for the buck for now still. Now the Cat 6 is becoming way more and more popular as by the year, but Cat 5e is still going on. All right, then we're going to move to Cat 6, category 6 Ethernet cable. See that you got a thicker wire already. So it's gauge 23. Right? The twist is tighter. And we have, now we have 2 speeds. Right? You can have 1 gigabit per second. So it doesn't, if you have a long wire of over 180 feet, then it just doesn't calculate to install Cat 6, which is way more expensive, because you're still going to end up with the specifications of Cat 5e. If the run end-to-end is up to 180 feet, then you can get 10 gigabits per second transmission through that. So it is important to know. Somebody wants Cat 6, and say, okay, how long are your runs going to be? If they're like 250 feet, you know what? You might as well get Cat 5e, because you're just going to pay for nothing, right? You're not going to get any benefits out of that, unless you're trying to get the the analog transmission. Okay. So again, the maximum distance is 300 feet, but if it's 1 gigabit per second, now up to 180 feet. So if you're talking about Cat 6, and if you get the full benefit of that, you are cutting yourself with the maximum distance from one end to end. That's why Cat 5e is still going strong as well, because you get a short thing for what you know what to expect. And then here's the analog transmission, 250 megahertz for CCA, copper-cladded aluminum, or the 500 megahertz of bare copper. It's mostly commercial use. Although some people, when they build their own houses, they choose to install Cat 6 wiring in their house. Okay. Then there's Cat 6A, again, 23. The twist is tighter and more consistent, but you get the full 300 feet. The cable is way thicker. It almost looks like a coaxial cable, like a cable TV cable, or the cable that you get internet, way thicker. But you get the 10 gigabits over 300 feet, and you get 500 megahertz, and you gotta have bare copper on that one. Okay, there's no copper-cladded aluminum for this, and it's called, again, mostly commercial use. Then you have Cat 7, 10 gigabits, 300. You get more analog bandwidth here. Cat 7A, tighter twist, and you get 40 gigabits per second up to 160 feet. You see, you gotta know that stuff. So you're gonna keep that table here, and you're going to expand your knowledge, but you know what to look for now. And then it has 100 gigabits per second, but only up to 50 feet, just 50 feet. And it has
1,000 megahertz, or I put in bracket 1 gigahertz, is because when it comes to analog transmission, the tech talk would be in megahertz. Okay, somehow it's just stayed that way, that people talk about megahertz when it comes to analog transmissions or bandwidth. Okay. Then Cat 8, unknown gauge, I think it's still in progress, not that much used, if it ever exists, but there's some specifications leaking through, whatever. So 300 feet, 200 megahertz bandwidth, 40 gigabits per second, up to 300 feet, question mark. Development in process. Now, this was a couple of years ago they did that, so maybe they have developed that, maybe they just abandoned that, because you know what, you might as well go with fiber when you're talking about this kind of bandwidth and stuff, right? So just before I leave this slide here, transfer speed, this is the digital ones and zeros. You're going to have a different rate because there is modulation involved, and the principles apply slightly different when transmitting the digital pulses or a full-fledged analog signal. This would be digital transmission, would be between your router or your modem, actually the modem, between your modem and your inside network wiring. You get the Ethernet, you get the digital transmission going on. Now, the signal from the outside, so the internet is brought into the building from outside in an analog form. So it goes into analog form, it hits the modem, and the modem transfers that into a digital signal. So the modem modulates the signal into the digital signal from the analog, and then it demodulates that into the one way. So it modulates and demodulates, modulating, demodulating, modem. That's how it's got its name, all right? All right, now, wiring details. Okay, we have the 5 o'clock here. Again, I was going to say I'm going a little bit over time here. So if you need to leave to do whatever else, you can leave and you can just come back and see this thing on YouTube. You can just finish it up. But I'm just going to keep going. We have a short term. This is only 7 weeks. I want to give you as much information as possible. So I'm getting you the most, or the least of the most, or the most of the least. You still should be able to get certain substantial information before you leave this school. Okay, so there you go. Wiring details. Okay, standard T568 wiring details. Okay, so here is a modular plaque. We're going to do a lab on that. What do you do when you need to go further than 300 feet? Thank you for asking this question. I'm going to explain that. I'm really glad, because I can see that you're thinking. I can see that you're not just listening to me talking. Thank you, and I'll come back to it very quickly. All right. It has something to do with the MDF and the IDFs. IDF stands for intermediate distribution frame, and MDF stands for what's going on here? And MDF stands for what's going on? Oh, I get some stuff going on. MDF stands for main distribution frame, and IDF stands for intermediate distribution frame. I think I was talking about that last time, but now you can just kind of connect that information with this information here. I know what, I'm just stop here and explain that. All right. Let's say you have a large department store with covers a huge area. Let's say it's out, something like a Home Depot or Lowe's or Rona or whatever. So you have a huge area to cover. Okay, and let's say here is the main distribution frame, MDF. Okay, so that's all the communications. That's the main communications from all the telephone lines from outside coming here. All the communication happening. That's the heart, that's the core of this whole building. But over here there will be a far, so it will be more than 300 feet, so you won't be able to do it. Plus maybe you have a garden center somewhere here, so that's even further, right? So what you're going to do is you're going to employ strategically, usually along the walls. That's going to be IDF, DF, IDF, IDF,
All right. So there'll be ADF-A, IDF-B, IDF-C. All right. So those they're strategically placed. So the runs will be Cat5e are no longer than 300 feet to whatever is around that, and then there will be that will be servicing all that no longer than 300 feet. And then you're going to get those long runs. Instead of having a copper wire, you're going to get fiber optics going in there into the main distribution frame. So that's how those things are being solved. Okay. Thank you. Thank you for asking that question here. All right. So let's go with this thing here. This is a modular plug, RJ45. RJ stands for registered jack. Just to have some standardization, and the standard is T568 wiring standard. Okay, now we're going to have T568A or T568B. And remember, when we were connecting during our lab, those jacks they had the A or B configuration. So there you go. All right, so that's T568A or T568B, and in Cat5E, you only exchange the oranges and the greens, and the blues and the browns stay as they were. That's only up to Cat5E, but I'm getting ahead of myself a little bit here. All right, so the pins we count in this way here. Remember when we were doing testing and it showed that one wire is broken or one is missing? Just by looking at the screen, I could say, okay, that's white, orange, because I was able to count the pins on the wire map that the tester would display. All right, so the pins, when we have that latching clip pointing away from you and the prongs facing away from you, that's how you count the pins from left to right. 1, 2, 3, 4, 5, 6, 7, 8 pins. All right. 4 pairs, 8 pins. So that's how you count the pins. This is not how we count the pairs. And this is T568 standard for Ethernet connection. We count the pins in a certain way. And for the POTS, which is plain old telephone service, we count the pairs in a different way. All right. For the POTS, let me just quickly make room for more writing on the wall, writing on the glass. POTS. POTS stands for plain old telephone service. This is the telephony, the most basic telephone service that it gets. All right. And we have 8 pins, remember? See, you have 8 pins here. Right? So let's say 1, 2, 3, 4, 5, 6, 7, 8. That's when the jack is pointing forward and the latching clip is pointing away from you. Okay. And here's the wire. I mean, so that's the jack. Just get more light into that. All right, so here's the pins. 1, 2, 3, 4, 5, 6, 7, 8. Now, pair number 1 in POTS is here. 4 and 5. That's the pair number 1. Pair 1. 1. And then, as we go along, pair number 2 is going to be away from that, and away from that, and away from that, and away from that. So pair number 2 is this. Okay, here, pair number 2. Pair number 3. Pair number 4, and so on. So that's the POTS configuration. We just built outwards. Plain old telephone service. That's the telephony. Right? Simple, right? Then we go T568, Ethernet. Again, we have a jack. All right. Make things clear here so you can see things. We get Again, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. These are the pins.
And we count them as we count them. With holding the jack with the latching clip facing away, and we're looking at the prongs, 1, 2, 3, 4, 6, 7, 8, counting from left to right, just as we write things. So again, pair number 1 is still the 2 middle prongs. Pair 1. You see that? Pair 1. All right. Pair 2. Again, it goes outwards. Pair 2. And that's as far as the similarity between T568 configuration, Ethernet. Then we have pair 3 and pair 4. So here's pair 3. And here is pair 4. That's how we count the pairs in the T568. That's Ethernet, yes. Right. So you can just do a little dance. There goes pair 1, pair 2, pair 3, and pair 4. Right? Somebody write music to that. I keep always saying that. You remember the dance? You're a cable guy. 1, 2, 3, and 4. Don't ask me to do it again. Okay, I'll do it. 1, 2, 3, 4. Okay, whatever. All right, so that's how we count the pairs. So let's go back to the slideshow here. Now, T568 wiring details. All right, you see here 4 and 5. You see the blue. So pair number 1. How do we count the colors? Remember the 25 pair exercise that we did? The designation colors, not the group colors. So it's blue, orange, green, brown, and there will be slate, but there will be the 5th pair. The Ethernet cable only has 4 pairs. So pair 1, 2, 3, and 4. Right, so this would be pair number 1. That will be the blue. That will be orange. This would be green. And this would be brown. Okay, so T568A configuration. All right. So again, we see the blue, orange, and then with green and brown. So this is as if you were standing here and the jack is facing that way away from you. All right. The color solids and stripes is that when you're holding that, so this is the rear of the jack, this is the front of this jack. The blue pair solid goes on the left and stripe goes on the right. Everything else, you go stripes on the left. So easier to remember is that the stripes are going to the left always, except for the blue pair. It's just how they did that, whoever they are, okay? So here, again, blue, orange, green, and brown. Everything has the stripes on the left. So I'm looking at the A configuration, this here, this, oh, I can't, oops. Go back. All right? So stripes are on the left, except for the blue pair. So that's A configuration. When it comes to Cat5, if you want to make B configuration out of that, you just reverse the oranges. You just exchange the oranges and the brown, and oranges and the greens. Right? One is transmission, the other one is receiving pair. Which one is the transmitting pair? Which one is the receiving pair? That depends on which end you're looking at from, okay? Right, so, but the transmission goes, and it's only one way on one pair. So one pair would be transmitting pair, sending signal one way. The other pair would be sending signal the other way. Cat5e, the blues and the browns are not used, just the orange and the green are being used in Cat5e. So if you have a Cat5e installation in the building, usually maybe a camera or something that requires a Cat5e connection, if you run the test and it's difficult to pull wire or way more expensive to pull the wire, as long as you get the oranges and greens going, then you're okay. You should be able to have that link established. So this cable is not going to be certifiable as Cat E, fully fledged Cat E link. However, it's going to work because now you know that only greens and oranges are being used in Cat5e. In fact, if you look at some of the patch cords, and the patch cords are the connecting cables that you plug in, one to the wall, the other one to the computer, some of the less expensive or the economic patch cables, you're going to see only oranges and greens, and the other prongs are going to be empty. They're just not going to be used. Some of the Cat5e. So which one is transmitted and which one received? If you got the NIC, which is network interface card, which would be the Ethernet port on the computer, for example, then the green would be transmitting and the orange would be receiving. If it's a configuration A, right? Again, on the other side, the green would be receiving port on the port. This will be the switch or a hub, okay? Then this will be transmitting and receiving. So that's how you can tell. Now, that's when you want to plug in the computer or PC or a wireless access point or whatever is standardized to the regular standards of standardizing thing. You're going to have that. You're just going to use straight links to plug into the switch. But what happens if you want to connect two computers to each other, not through a switch? You can, for some reason, you might want to do that. Well, if you have those two similar ports, you will be connecting one transmit to transmit and receive to receive. You're not going to have a communication happening. So that's why we're going to do something that is called a crossover cable, right? And some equipment requires crossover cable. So you just basically do configuration A on one side and configuration B on the other side, and you can connect those two same terminals together because the transmit is going to talk to receive and the transmit on the other side is going to talk to receive on this one here. So that's why sometimes we need crossover cables. That's Cat5e. Now, what you're going to see sometimes, if you Google a crossover cable, you might get confused because you're going to see sometimes something like this here on that picture that is I'm showing here. And sometimes you're going to see more cables. You're going to see the blues and browns also crossed with each other. Well, the reason for that is, can we see that? Yeah, so this would be, see on the tester, this would be pins 1, 2, 3, 4, 5, 6, 7, 8, and shield is not connected because that's in case we had the shielded twisted pair. Now, this one shows failure because it was testing for a straight link. So it fails a straight link. But if you see this particular pattern here, that means you're having a cross-connect wire. You're testing a cross-connect wire. So sometimes you want to see that. But it will be cross-connect for Cat5e. Okay. And sometimes you're going to Google a crossover cable, and you're going to see more cables crossed. As I said, blues and browns are also exchanged. So what gives? Okay, what's going on here? It's a head scratcher, right? Well, that works only, the oranges and greens, that only works with Cat5e, up to Cat5e, because Cat5e only uses orange and green. Now, Cat6 is using all 4 pairs. It's also using blue and brown. So if you want to make a crossover cable with Cat6 and up, you also switch the browns and the blues. So that's why. So the confusion is solved. That will be the T568 crossover cable involving Cat6 and up cable. All right. So that's pretty much it for today's lesson. We went 20 minutes over. Well, I could tell you much more. I could be talking for 10 years about this thing. Maybe not. Where's the switch? Here's the button. Any questions about the assignment or anything that the test or anything like that? The test, I'm going to, as I said, probably I'm going to employ, I'm going to deploy the test probably on Monday. Just give me some part of the weekend so I could finish up those questions. I always try to get as many new questions as possible. I think I will have to start working on the assignment before I have questions, but I haven't started it yet. Well, I'm giving you the ammunition for the assignment bit by bit. So, but now I gave you the paperwork so you can look at this thing, think about it, see what is it that you have some blockages, maybe not enough information. And I'm going to feed you that information all the way. And then you're just going to sit down and it's going to take you maybe an hour to just go from, now the labor cost, you don't need any information. You can just calculate the labor cost just like that. Right. The other things, just going now, I'm giving you the information about the roughing in, and other things like the service loops. What's a service loop? Why do we need that? And so on. So you're not just going through the motions. You know why you're doing things that you're doing. And let me tell you that right now it's a kind of easy talk, easy listening. But once money is involved, and if you're coordinating a project and you're trying to price things out, then the pressure is on. And a couple of first jobs that you're going to quote, you're just going to be slightly nervous because you don't want to miscalculate something. So instead of making money, you're going to lose money. And the bigger job, the easier it is to lose money, because in small jobs you make small mistakes. In huge jobs, if you miscalculate the wire amount or the labor hours, then you can come up with huge differences. All right. So that's why I'm just giving you things bit by bit, so you understand not only what you have to do, and I just want you to know why you're doing this. All right. Okay. Any other questions? If not, you're always welcome to send me questions by email or ask me during the lab time. All right. So that's it for today's lesson, and enjoy your weekend, guys. The lockdown is almost over, but it's not over yet. If anybody saw the movie The Walk, it was the guy about in 70s when the trade towers were built. So he extended the line between those two and he was walking. And as he was training to do the walk on the line, his teacher or his master or whatever, he was telling him that even if you go to the end, you still have to do the final two steps, because if you don't do those right, you can still fall down. So, that's the same kind of analogy when this lockdown thing here we're almost there, but we still have to make those final two steps. So stay healthy and safe, and I will see you when I see you. Thank you, guys.